stay a while and listen.
Aging, Why Does Evolution Kill? A new book proposes a radical theory of why we age. December 19, 2025. Share. Why do we age at all, and why do different species age at such dramatically different rates? After decades of longevity research, biologists still disagree on the most basic questions. What is aging? Is it possible to stop or reverse it? And what strategies stand a real chance of working? Most gerontologists explain aging as the gradual accumulation of cellular and molecular damage, much like rust in a car or the decay of a house. But this viewpoint struggles to explain a series of biological paradoxes. Tiny sparrows can live 20 years. Naked mole rats survive twice as long. Hydra and planaria appear not to age at all. Queens in eusocial species can live 50 times longer than workers with the same genome. Some animals, jellyfish, comb jellies, and eusocial insects, can rejuvenate, yet they do so only under stress, not under ideal conditions. If youth is mechanistically available, why do they choose aging and death? A new book, titled Aging, Why Does Evolution Kill?, written by Hong Kong-based Professor Peter Lidsky, and published with the support of Open Longevity, offers a bold, non-orthodox answer. The book argues that classical evolutionary theories of aging are inconsistent with recent empirical and theoretical results, and develops instead a novel pathogen control theory of aging, in which aging is not just damage, but an evolved, adaptive program. Early evolutionary thinking, dating back to August Weismann in the late 19th century, proposed that aging is a programmed process that removes maimed individuals from a population. This view fell out of favor because it relied on group selection. Individuals supposedly sacrifice their own fitness for the good of the species, a mechanism later considered too weak to explain such costly traits. As a result, for much of the 20th century, theories of programmed adaptive aging were largely abandoned, and non-programmed, damage-based explanations took over. Lidsky's pathogen control theory revives the idea of programmed aging but grounds it in kin selection, the same well-accepted evolutionary force that explains parental care. As J.B.S. Haldane quipped, he would give his life for 2 brothers or 8 cousins, a vivid illustration of kin selection, in which an individual may sacrifice even its life if this helps relatives, who share its genes, to survive and reproduce. How, then, could death from aging ever help one's 2 brothers or 8 cousins? The book's central claim is that the missing piece is chronic, sterilizing infections, pathogens such as syphilis or gonorrhea in humans, which do not kill quickly but prevent reproduction. Individuals carrying such infections become evolutionarily worthless, they cannot have offspring, and they can transmit these infections to relatives, harming their genetic interests. In this context, the early death of infected, non-reproductive individuals can be favored by kin selection. Because the probability of acquiring such infections increases with time, evolution, according to the pathogen control theory, can favor mechanisms that remove older individuals as a function of age. In this view, aging is an immune strategy, a program that sacrifices older individuals to protect their kin from the infections they accumulate over long lives. This perspective leads to a series of striking, testable predictions. If aging evolved to protect relatives from infection, then the population structure, who interacts and infects whom, becomes a major determinant of lifespan and aging patterns. The book argues that many outlier species fit this logic. Eusocial insects, naked mole rats, salmon, flying birds, and bats all have atypical population structures that can explain their unusual aging and death schedules. In the closing chapters, Aging, Why Does Evolution Kill?, explores the implications of the pathogen control theory for modern gerontology. It places aging squarely within the context of the immune system and outlines new research directions that could reshape how we think about interventions to slow or reverse aging. The book presents an ongoing research program. Many of its hypotheses remain to be rigorously tested, and readers are invited to evaluate the theory critically. Whether or not one ultimately accepts the pathogen control theory, this book offers a provocative rethinking of one of biology's most fundamental problems. It will interest researchers, clinicians, and lay readers concerned with aging and longevity.